Hey everyone, you're listening to the TEN7 Podcast, where we get together every fortnight, and sometimes more often, to talk about technology, business, and the humans in it. I'm your host, Ivan Stegic. We've talked about DevOps at TEN7 on the show before. We've done an episode on why we decided to expand our hosting offering to Linode back at the end of 2017. We've talked about why we think it's important to have a good relationship with your hosting company. And we've written about automation and continuous integration over the years as well. For the last year or so, we've been working on our next gen of hosting service, and our DevOps engineer, Tess Flynn, has been deep in the weeds with Kubernetes. Today, we're going to spend some time talking about what we've done and how you could be doing it as well, given that we've open sourced all of our work. We're also rolling out training at Badcamp this year. That's in October of 2019. And we'll be at DrupalCorn as well in November. So we'll talk about that and what you might learn by attending. So joining me again is our very own Tess Flynn. Hello, Socket Wench.
Hello.
Welcome. I'm so glad you're on to talk shop with me. I wanted to start with why. Why are we hosting our own sites and those of our clients? There are so many good options out there for WordPress, for Drupal. You've got Acquia and Pantheon, Bluehost, others. We typically use the provider that makes the most sense based on our own clients' needs. We've had a close relationship with IP House and their managed hosting services for a long time. But why start hosting now? For us as an organization, it's kind of been the perfect storm of circumstances, from the technology being mature to the cost of it and the availability of it, to where we are as an organization from a developmental point of view, to even being more conscious of vendor lock-in and actively trying to avoid it. So I want to talk about technology a little bit more with you, Tess. What's so different now than it was a few years ago? Why is it suddenly okay for us to be hosting ourselves?
There's been kind of an explosion over the last few years of managed Kubernetes hosting providers. Now, we've had managed hosting providers forever. We've had things that are called infrastructure as a service providers. That's going to be things like AWS and Google Compute Cloud, as well as other providers, including DigitalOcean, but also, say, Linode and other ones, which just provide raw hardware, a VM, and a root login. Lately, however, a lot of people would rather break up their workloads into containers using something that's similar to Docker. And I've talked about Docker before, but Docker is an alternative take on virtualization technologies, which works on taking applications and putting them in their own individual virtual environment. I'm glossing over so many things when I say that, but yes. It gets the general point across within 2 minutes before everybody else falls asleep.
Right.
And the thing is that what's really nifty about putting applications into a container is that now the container doesn't really care where it is. You can run it on your system, you can run it somewhere else, you can run it on a hosting provider. And the great thing about these containers is that you can download ones that other people have created, you could modify them, you can make your own, and you can string them together to build an entire application service out of them. And that's really, really great. It's like infrastructure Legos. But the problem is, once you get the containers, how do you make sure that they're on the systems, on the actual hardware, where they're supposed to be, in the number of copies that they're supposed to be, and that they can all talk to each other, and the ones that aren't supposed to talk to each other can't? That's a lot trickier. And for a long time, the problem has been that you really only have two solutions. You do it yourself, or you're going to use something like Docker Swarm. And I don't have the greatest opinion of Docker Swarm. I have worked with it before in a production environment. It's not my favorite.
It's a little tough, isn't it? We've had a client experience on that.
It's a little tough, yeah. And it's not really set up for something like a Drupal workload.
Right.
It's set up more for a stateless application. Like a prototypical example is calculate, say, the progression of matter within the known galaxy, factoring a certain cosmological constant. Take that variable, set it into a compute grid, and go, hey, tell me what the results are in 15 years. But you don't really do that with Drupal. With Drupal, you're not just going to send off one thing and always get the same thing back. There's going to be state, which is preserved. That's going to be in a database somewhere. And there's going to be files that are uploaded somewhere. And then you have to get load balancing involved. And then it gets really complicated. And it's like, and I really didn't like how Swarm did any of this stuff. It was very prescriptive. It was, you do it their way and nothing else.
No flexibility.
No flexibility at all. It was really, really not fun. And it meant that we had to do a lot of modification to how Drupal works and incur several single points of failure in our infrastructure in order to make it work in Swarm. And that whole experience just did not really get me interested or excited to make a broader Swarm deployment anywhere else. And then I ran across Kubernetes, and Kubernetes has a very different mentality around it. Kubernetes has more different options for configurations, and you can tailor how Kubernetes manages your workload rather than tailoring your workload to work with Docker Swarm. And that's why I really liked it. And what was really nifty is once you have Kubernetes, now you have an open source project which is platform agnostic, which doesn't care about which individual hosting provider you're on. As long as you have containers and you can send configuration to it somehow, it's fine. It doesn't care. And a lot of managed hosting providers are going, hey, VMs were kind of nifty, but we really want to get on all this container stuff now, too. Oh, hey, there's a container, quote, orchestrator, which is what Kubernetes is and what Docker Swarm is as well, a container orchestrator, which does all of the make sure the containers are on the right systems, that they're running, that they can talk to the containers they're supposed to, and they can't talk the containers they're not supposed to. And that made a lot of infrastructure providers go, this is not really a platform as a service anymore. This is another form of infrastructure as a service. And as such, that is a segment that we can get into. And so first it started with Google Kubernetes Engine, which is considered still today the de facto version. Amazon got into it. Azure got into it. And all of these are pretty good, but like a lot of these huge cloud service providers, you can't get clear pricing out of them to save your life.
Yeah, that's so frustrating as a client, as a business owner. How do you do that? It's insane.
I mean, the only way that it seems that is deterministic in order to figure out what your bill is going to be at the end of the month is to spend the money and hope that it doesn't kill your credit card.
Yeah, right. And then try to figure out what you did and the ways of changing it. And then, hell, you're supposed to just be charged that every month from now on, I suppose.
And it's just a pain. And it wasn't any fun whatsoever. So an alternative approach is you could actually install Kubernetes yourself on an infrastructure as a service provider with, regular VMs. And I did this.
And we considered that, right?
It, and I even spun that up on a weekend myself. And it worked. But the problem is I'm a colossal cheapskate, and I didn't want to spend $30 a month to support it.
If only there was a supporting ISP that had free Kubernetes support and just charged you for the compute engines that you used.
And I was really just kind of sad that there wasn't one until 8 months ago, something like that, when DigitalOcean announced that they have in beta, and now it's in production, a Kubernetes service where the pricing was incredibly clear. You go to the cluster page, you select the servers that you want to see, the nodes, as it were. I know, Drupal nodes, infrastructure nodes, talk to network people, it gets really confusing. Don't even get physics people involved. It gets really complicated.
No, please, no, don't.
But no, you select which servers that you want to have in your Kubernetes cluster, the sizing, and the price is just listed right there in numbers that you can understand.
Per month, not per minute.
I know, per month, not per minute.
It's just a small things.
And
it's crazy.
It really targeted the kind of market that we're in for a hosting provider. And it made me really excited, and I really wanted to start putting workloads on it. And that's what started the entire process.
Yeah, it really was a kind of a fortuitous series of events, and the timing kind of just really worked out. And I think one of the biggest things for us, for me, is that with Kubernetes, we don't have to worry about patching and security updates and monitoring them, and these large hardware machines that we have to keep patched and updated. Essentially, it's updated every time we do a code push, right? Like we're still concerned with it, but it's a much easier burden to bear.
Right. Now, what's going on is that every time that we do a push, we're literally rebuilding every system image necessary to run the underlying application, which means that if we need to push a system update, it's really just a matter of updating the underlying container's base image to the newest version. And we're already using Alpine Linux as our base containers, which already is a security-focused minimal. Container set.
So this is actually a good segue in what I wanted to talk about next, which is a few years back as opposed to 6 to 9 months back, which is how we kind of got down the road to get to Kubernetes. Was I think the origin of all of this really is Flight Deck, and the desire for us to make it easy for developers who work at TEN7 and anyone else who uses Flight Deck, honestly, to have the same development environment locally. Like basically, we wanted to avoid using MAMP and WAMP and different configurations so that we could eliminate that from any of the bug squashing endeavors that we were going into. So let's talk about how this started with Docker and led into Flight Deck, and what a benefit it is to have the same environment locally as we do in staging and production.
So there's a joking meme that's been going around in DevOps cycles of a clip of a movie where I think a father and son are sitting and having, a very, very quiet talk on a bench somewhere in a park where the kid is saying, "But it works on my machine." And then the dad hugs him and says, "Then we'll ship your machine." And that's kind of what Docker does. But joking aside, I wanted to get that out of the way so that I'm not taking myself too seriously. So one of the problems with a lot of local development environments, and we still have this problem, is that traditionally we've used what I consider a hard installed hosting product. So we're using MAMP or WAMP or Acquia Dev Desktop, or if you're on Linux, you're just installing Apache directly. And all of those work fine, except when you start working on more than one site and more than one client. And so suddenly you have this one problem where this one client has this really specific PHP INI setting, but this other client can't have that setting. And MAMP and WAMP work around this through a profile mechanism, which underneath the covers is a huge amount of hyperlinking and weird configurations and spoofing and like, ugh.
Yeah, it makes me cringe just
shudder.
Talk about it, yeah.
And the problem is that every time you have to do this, every developer has to do this themselves. They can't just standardize on it. So if somebody has an individual problem on their system that only happens on their system at 3:45 on a Thursday after they've had chili for lunch or something or other, then you can't really reproduce it. So the solution really is you need to have replicatable, shareable, consistent development environments across your entire team. And that's what Docker does. Docker provides that consistency, that shareability, and makes sure that everybody does, in fact, have the same environment across the board. That's the entire point of it. And that's where the whole joke about, well, then we'll ship your machine, because that is, in essence, what containers are. They are system images that run particular bits of software. Now, once we moved everyone to Docker for development, we now had a consistent environment between all of our systems, so that now we didn't have to worry about a number of different problems. Another good example is this site uses PHP 5, this site uses PHP 7, a little out of date now, but it was very relevant 2 years ago. And in which case, how do you make sure that you're on the right version? Well, with Docker, it's you change a text file and then you boot the containers up, and that's it.
And that text file lives in a code repository, right? And so everybody else gets that change.
Because you are literally sharing the same environment. You are enforcing a consistent development environment across your entire team for each individual project. And if you use that strategy, you have something that is flexible, yet at the same time incredibly consistent.
And this is really important across all of our developers and all of our local development that we do. But the challenge then becomes, how do you consistently replicate this in a staging or a test environment, and even in production? So that's kind of the genesis of how we thought Kubernetes could help us here, right? So the challenge to you from me was, how do we make this work in production?
So the nice thing about Flight Deck is it was always designed with the intention of being put into production, but the orchestration component just wasn't there, and the hosting component wasn't there. Kubernetes showed up, that solved the orchestration component, and then eventually DigitalOcean showed up, and now we have the hosting component. So now we have all the pieces together to create a consistent environment that is literally the same containers from the first time that someone starts working on the project to when it gets deployed to production. That is the height of continuous integration ideals, to make sure that you have consistency across all of your environments, that you don't have different weird shared environments along the way, that everything is exactly the same so that you know that it will work.
So I want to stop right there, and just so for listeners can appreciate the power of what you just said. You basically said, I am going to be working on a website or a web application locally with some sort of stack of required server components whose version numbers and installation profile is configured in a certain way. My teammate is able to replicate that environment exactly to the version simply by using the same repo and by using Flight Deck. Moreover, all of those version numbers and the stack that is being used is actually also the same now in staging, and most amazingly to me, in production. So we can guarantee that what container is functioning in production on the Kubernetes cluster is actually on staging and on everyone else's machine. We've totally eliminated any variability and any chance that the environment is going to be causing an issue that one person may be seeing and that another isn't.
That's correct.
That's pretty amazing.
It's a really difficult thing to do, but starting with the containers and building that from the base up actually makes it a lot easier. And I don't think that any other local development environment, even container-based local development environments such as DDev and Lando, are doing this quite yet. They have, last I heard, I think DDev was working on a production version of their containers, but it's not the same containers. Whereas Flight Deck, it literally is the same containers.
It's the same configuration. Everything is the same.
Mm-hmm.
Yeah, that's pretty amazing. And I'm still kind of really impressed with all of the stuff that we've done and that you've done. And honestly, this is all open source too. This is not like TEN7's proprietary product, right? We've open sourced this. This is all on the web. You can download it yourself. You can figure it out yourself. You can do this as well. You can start your own hosting company.
That's correct. The key item which puts all this together is a Ansible role called Flight Deck Cluster. And what Flight Deck Cluster does is it will create a Flight Deck flavored Kubernetes cluster. And it works perfectly well on DigitalOcean. There is no reason why it can't work on, say, Google Kubernetes Engine, or AWS, or anyone else. The architecture that Flight Deck Cluster uses is meant to be simple, durable, and transportable, which is something that a lot of other architectures that I've seen just don't have.
So we've designed a lightweight set of Docker containers called Flight Deck that you can use locally. We've evolved them so that they work with Kubernetes, which you can deploy anywhere in staging and production. We've open sourced them. And the fact that it runs Kubernetes, all you need is a service that supports Kubernetes, and you should be able to run all of this in those other locations. So we've talked about how we started with Docker and how that evolved, and I've talked about how we've open sourced it and it's available to you. I want to spend a little bit of time getting into the details, into the nitty gritty of how you would actually do this for yourself. Is there an app I download? Is it all the YML, all the YAML files that we've open sourced? Like, what would someone who wants to try this themselves, what would they have to do?
So the first thing that I would probably do is start running Flight Deck locally, because you don't need to pay any extra money for it. You just need to use your local laptop. And it's also a good experience for you to learn how to interact with Docker by itself. That looks good on a resume, and it's a good skill to actually have. I have a talk that I used to give about Docker, and I know that there's a blog post series that I posted somewhere a long time ago about how Docker actually works under the covers. And both of those are going to be invaluable to understand how to get Flight Deck working on your local environment. And once you have it working on your local environment, then the next problem is to figure out the build chain. Now, the way that our build chain works is that we have another server, which is a build server. And what the build server does is it's going to receive a job from GitLab, and that job is going to take all of the files that constitute the site. It will build them into a local file system, and then it will put those inside of a container, which is based on Flight Deck. Then it will upload those to a container registry somewhere else, so that we already have a few additional pieces of technology involved. But the nice thing is GitLab is open source, Ansible is open source, and all of our build processes are run through Ansible. And the Docker registry is also open source. It's just a container that you can run somewhere. There's also services that you can buy that will actually provide you a container registry on a fee basis. All of those are definitely options. Once you have the container in a registry somewhere, then you can run Flight Deck Cluster to build out the rest of the cluster itself.
You make it sound so easy.
I make it sound easy, but it's a lot of code. But it is all open source, and it is all there for you to use. Right now, our cluster is based on a development version of Flight Deck, which I've been calling Flight Deck 4. And this version is intentionally natively designed for a Kubernetes environment, but it still works perfectly fine under Docker Compose locally. And it is literally the containers that we are using in production right now at this minute. All of those containers have been thoroughly documented. They have nice READMEs which describe exactly how you configure each individual container. And the Flight Deck cluster role on GitHub also has an extensive README document which describes how every individual piece is supposed to work.
So the easiest way to get to all of that documentation into the repos is to simply go to flight-deck.me. So flight-deck.me, that will redirect you to a blog post about Flight Deck on the TEN7.com website. And at the bottom of that post, you'll see links to the GitHub repos and all of the other information that you'll need to get to that. Yeah, so I wanted to talk about kind of the fact that the hosting itself, the Kubernetes hosting that we have, is optimized for Drupal right now. I kind of struggle to say optimized for Drupal. It's just configured for Drupal. There's no reason that Kubernetes is, and what we've released is, locked into Drupal. We are hosting our own React app on there. We have a Code Igniter app that's running. We even have a Grav CMS site on it. There's no reason why you couldn't host WordPress on it, or Expression Engine, or any other PHP, MySQL, Apache, Varnish stack on it, right? There's like nothing innately like that forces you to be Drupal on this, right?
Nope.
And that's also, from a design perspective, that was always the intention.
It's intended to be run for Drupal sites. However, it always keeps an eye towards being as flexible as possible.
So I think that's an important thing to mention. Let's talk about some of the challenges of running Kubernetes in a cluster in production. I mean, it's not like running a server with a local file system, is it?
Oh, no, it isn't.
Okay, let's talk about the problems, not the problems, but the opportunities of things to learn.
So the biggest, scariest thing about Kubernetes and Drupal is you have to let go of your local file system. That is the most scary thing that I have to tell people about Kubernetes.
So no file system, huh?
No file system.
Does that make it slow?
Well, not really. Let me describe why. So the problem is that, and I've had this in my Return of the Clustering talk, is that we're used to something which is called block storage. Now, block storage is pretty great. It is a literal attached disk to the server. So it is mounted on the server, you have direct access to it, and you can store all kinds of things to it, and it's fast, and it's right there. It has no failover, it can't be shared across the systems, but whatever, we have one big server, who cares about that? And then if you do try building a traditional server cluster, well, you can't quite do that. So then you get network file system involved, NFS. And then now all of the file reads and write occur over the network to some other centralized server. Okay, it still looks like a local block storage. It still works like block storage. So okay, sure. But the problem with that is that network file systems, by their base nature, introduce a single point of failure. Now, that's not good by itself. If the NFS server goes down, your entire site no longer looks or functions correctly. But the problem is that it also doesn't scale either. There's a natural limitation between the number of different replications for front-end servers that intercept the actual requests from people and then send them to the Drupal backend for processing and then push back the responses. There's a natural limitation between those systems and those that can access NFS. And as soon as you have too many accesses, suddenly NFS is not going to be keeping up with you and your performance drops to the floor. Also, NFS is kind of persnickety. You have to tune it. You have to make sure that it has enough RAM, enough bandwidth. You have to make sure it's physically proximate to the rest of the servers. And all of this is because it's trying to replicate block storage. Now, block storage is great for a whole bunch of data, but in a cloud architect's perspective, there are really two different kinds of data. There's complex data and static data. And when I tell people about this, they go, well, what's a complex file? And a lot of people will say, well, I mean, we have a whole bunch of files which are all linked together. That's complex, right? Nope. Well, we have some Excel documents that's on an NFS file system. That's complex, right? Not really. So what is a complex file? And I spent hours trying to squeeze an answer out of the internet for this. And eventually I arrived at the answer of, from a cloud architect's perspective, complex files are going to be such as the files which constitute the actual underlying disk storage for, say, a MySQL database. Data which is written sparsely and seemingly randomly in multiple locations at multiple times with strict concurrency requirements. Now, when I say that, does that sound like anything that we actually upload in a Drupal site?
Nope.
Nope. None of it does. Block storage is required for complex data, but for static data, which is virtually everything that a Drupal site hosts, we don't need it. It's too much. It's way too complicated, and it doesn't scale. So what's the solution? The solution really is we need to treat the file system like an API. We need to treat the file system like a database. We don't care where the database is as long as you have an IP, a login, and the correct credentials to actually get to the database, and then we have multiple readers, multiple writers. That's what we want for a file system, right? Well, it turns out there's a thing that does that already. It's called S3. And that's what we're using.
Yes,
S3.
AWS. Hello.
And the nice thing about S3 is it literally, it's perfect for static data, it's API accessible, and it can be made internally redundant, so it has its own high availability built in that we don't need to worry about. And the nice thing that's even more than that is when we say S3, most people go, oh, Amazon. No. S3 is in fact a standard. It is not just Amazon's implementation of S3. There are multiple implementations of S3. So I usually like saying an S3 compatible hosting provider. And that's going to include anybody who runs any kind of S3 compatible service. And there's actually an open source product called Ceph, CEPH, that actually provides an S3 front end for file storage. And that is actually a service that DigitalOcean also provides. They have DigitalOcean Spaces, which provide an S3 compatible static file interface that's actually powered by a Ceph cluster underneath the covers. So open source all the way down to the core.
Well, I didn't know that Spaces was Ceph underneath the covers. That's cool.
It's just buried in there. You can find it now.
Cool. So file storage is a challenge, but we fixed that by using S3.
Yeah, because Drupal 7 and 8 actually have very good S3 support. There's S3FS, that particular module, which is excellent for doing Drupal 7 sites. We've been using Fly System for Drupal 8 for a few different reasons, but there are reasons that are a little bit easier for us. But your mileage may vary.
And if you're going to use, or if you're going to host something that's not Drupal related, you would need to find some other S3 compatible layer module, right?
Like for the CodeIgniter application, we are currently looking at implementing that as well.
And there's a React app as well that we've deployed that uses the underlying Drupal site, though, doesn't it?
Yes, that doesn't actually need a local file system.
There's no SSH access to a cluster of Kubernetes, isn't there?
Yes, that's the other thing. It's like after I've already brutalized you with saying, no, you can't have a local file system, now I take your SSH away as well.
But there is something to use it to replace it, right?
There is. The problem is that you really, 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 really shouldn't use SSH in Kubernetes. SSH is a very dangerous thing to have running anywhere because it is a potential security access point that can be used and abused both internally and externally. And you really don't want to have to run it because if you want to run SSH in Kubernetes, you have to run it in a container. And if you run it in a container, you're running it as root. And if you're running it as root, you're running it wrong on the underlying hardware that's powering the cluster. That's bad. You don't want to do that. So instead, you want to access what is typically called the backplane. And the backplane is going to be access to the workload via the orchestration system. And so for Kubernetes, the backplane access comes in the form of a command line application called kube control or kubi control or kube control or kubicuttle or like 15 other different names.
Let's spell it out so people know.
I'm always fond of kubicuttle, though. That's my favorite.
I like that one too. That's Kubectl, right?
That's correct.
Okay, kubicuttle.
And this application not only lets you interact with the orchestrator, but also allows you to directly access individual containers as well. And although getting to an individual container is a little bit more difficult, once you've done it a few times, it's not that hard. And because Kubernetes is so popular, there's a lot of other like command line environments which will have auto-completion assistance for kube control as well. So like for me, if I enter in a parameter to kube control, say for namespace, I can hit tab and it will give me a list of the namespaces that I have. So I don't actually have to type it out.
That's pretty slick.
I use Z shell, but that's me. I'm weird. Some people like using fish or some other shell. And I'm sure there's auto-completion mechanisms for your favorite shell somewhere.
There's not a whole lot of challenges then with Kubernetes. So you've kind of mentioned a few that are surmountable. Is there anything else a budding developer, a budding DevOps person should know about that are looking to start to explore hosting for themselves?
Well, they should also keep in mind that email is a problem.
Yes, we discovered that in the last few weeks, didn't we?
Yes, we did.
And we decided that we were going to use a external transactional email provider. We ended up on SendGrid, but you don't think of these things once when you're working on a cluster that's managed because, hey, these machines all have SendMail on them.
Yep. And that's one thing that you really can't rely on when you start working with a container-based workload. It exposes a lot of these things. But we're not where we were 2 or 3 years ago, where this would have been a huge, scary problem. These things have existing solutions, which are not that difficult to implement, even today.
And there are some free tiers as well that you can use, especially if you don't have a high volume of emails that you're sending out.
I mean, if you only are sending 500 emails a day, you can configure your G Suite to use as the SMTP provider.
Exactly. What about cron? Isn't that a problem too?
Cron is a little bit different in Kubernetes. So the thing with cron is that in Kubernetes, cron isn't just something which runs a command. In a traditional server workload, cron is some background process that exists in the system, and when a certain time shows up, it runs a certain command that you tell it to.
Yeah.
And it assumes that you're running it on literally the same exact system that is running everything else, your web workload, right?
Right.
That's not quite the case in Kubernetes. In Kubernetes, a cron job actually runs a container. So when you actually have your web workload, you're going to have one container, say, for Apache somewhere, which is running your site. And then you have a cron job in Kubernetes, and that cron job will literally spin up a completely separate container in order to actually run that process. So that's a bit different. Now, the only real part of that which gets really confusing is if you don't have a nice separation of all of the different infrastructure we've just finished talking about. If you don't have any local disks that you need to worry about, if you don't have SendMail you have to worry about, if you don't have any of this stuff and you can scale out your web containers to 10 or 20 or more and not have a problem because they all rely on external API-based providers, then it doesn't really matter what you do with cron. You just literally run the same container that you run for your web workload with the same configuration and everything else, but you only tell it to run a particular command instead of run Apache. And that's it. That's what we do. And it's actually not very hard.
What's your favorite thing about Kubernetes? And I'm only going to give you 5 minutes at the most.
I think the thing that I like the most about it is probably the ability to easily scale things. Once you actually have solved all the underlying infrastructure problems, you basically have just a container-based workload that you can say, I need to run 3 of these. And then you can just tell it will run 3 of them, and it will just run it. And that's it. You don't need to worry about it. It already load balances it for you. How can I describe this? Well, let's go back to the infamous car analogies again, because I'm
They work.
from the work, but
they
they
work.
work within a U.S. cultural context of a certain decade period, of a certain geographic location. But let's put that aside for a second. So a car analogy. Let's say that you have a car and you want to do some work on it. And you go to your garage, and what do you see? The car and an empty garage. That's often what a lot of other systems look like. When you have to do traditional clustering with regular virtual machines or even self-hosted physical machines, you have to go over to your local hardware store and buy all the tools and buy the car jack and buy an engine lift and buy an air compressor and a whole bunch of other stuff in order to do all your car stuff. And it's a lot of work and a lot of investment. With Kubernetes, it's more like, okay, I go to my garage and I have Kubernetes, so I have all the tools already. All the tools are just there on the walls right now. I can just start working. That's what I really like about Kubernetes. It provides me a room with all the tools for me to actually make this workload do what I want it to do, rather than having to go and grab yet another thing, and then another thing, and then another thing, and then try to make compromises to make 2 things which aren't the thing that I can't get right now, but they're the 2 I have to work together.
I love the analogy. I think that works. Tess. What about training? Wouldn't it be great if instead of trying to figure this all out yourself like we did, you could just have us show you how to do it?
Gee, wouldn't it?
Wouldn't it be great? Well, guess what? That actually exists. We're going to be doing some free trainings at Badcamp and then at DrupalCorn as well. So we'll be at Badcamp next month in October. That's the beginning of October. Now, they're free trainings, but there is a cost of use to attending the training itself. So I think you have to register, and it's like $20 or $10 at DrupalCorn. They're free as far as we're concerned. Can you talk through just a little bit about the format of the training that we have set up? What are you going to learn, and who is it for?
So we'll briefly touch upon different kind of Kubernetes hosting providers, as well as what Kubernetes actually is and what it does and what it gives you. And then afterwards, we're going to start containerizing your particular application. So we'll start working with containers, putting them onto Kubernetes, getting used to how to use kube control, how to work with individual definitions within Kubernetes, and making all of these pieces work together.
And it's a 4-hour workshop. It's half a day. You get to spend time with Tess, and I think I'll be there too. It's going to be great. So if you want to contribute to Flight Deck or to Kubernetes, the Kubernetes Flight Deck cluster that we have, we'd love it. It's all online. You can visit TEN7.com. You'll find it there on the What We Give Back page, and you can also visit us on github.com/TEN7, and you'll see all the repos there. We'd love your help. Thank you, Tess, so much for spending your time with me today. This has been truly great.
Not a problem.
So if you need help with your own hosting or figuring out what makes most sense to you, we'd love to be there to help you. Whether you're a developer or a large university or a small business, it doesn't matter. We're happy to provide consulting, whether that means deploying your own Kubernetes or having us do it for you, or even selecting another vendor that makes the most sense to you. Just send us an email and get in touch. You can reach us at hello@TEN7.com. You've been listening to the TEN7 Podcast. Find us online at TEN7.com/podcast. And if you have a second, do send us a message. We love hearing from you. Our email address is podcast@ten7.com. Until next time, this is Ivan Stegic. Thank you for listening.